today we'll be talking about ax squared plus bx plus c, and we're going to be talking about factoring it, especially when this little tricky boy, a, is greater than 1. And we're going to talk about one method called the AC method. But before we get there, I want to bring you through a document that's really cool. It's called the factoring flowchart. Okay, so here's the factoring flowchart. It's a Java type of script type thing. Okay, so we've already talked about greatest common factors. And what you always want to do is look for first as a greatest common factor. And if you have none, you move on to the next question, which is how many possible terms do we have? Okay, but if you do have a greatest common factor, you follow the yes path and factor it out. So you factor it out, leaving the greatest common factor. Okay, now how many terms? Now today we've just talked about ax squared plus by, so you would be taking this path of 3. So if you're factoring a trinomial or binomial, okay, we've already talked about that one right there. Okay, all right, we just talked about 3. Okay, now perfect square trinomial we haven't talked about yet. We did talk about how to multiply into a perfect square trinomial. We haven't talked about factoring, so we're not going to go down the yes path today. Okay, last time we talked about the no path. Okay, where if you followed it, you had 3. It wasn't a perfect square trinomial, and you went to this part right here, which was the coefficient of the first term equals 1. Yes, we have talked about that, and that was factoring the easy way. Okay, so we factored the easy way, which was x squared plus bx plus c equals x plus p times x plus q. And b was p plus q, and c was p times q. This is just a mathematical way of saying what two numbers multiply to get me c, but add up to b. Okay, today we will be taking the path of most resistance, which is the coefficient of the first term equaling 1. Okay, and we're going to say no, we're going to say it's something greater than 1, so we're going to factor it the long way using the AC method. Okay, so now that we've talked about it, let's talk about the actual steps. Now the actual steps are going to seem a little bit confusing than normal, but trust me, back when I was learning how to do math, it's an infinitely easier method than what you might think, okay? Alright, so here's the actual method. So we start out with our trinomial. Let's say we're given 2x squared plus 9x plus 4. Okay, and we have to factor this. So what we're going to do is first out, we're going to start by identifying what A, B, and C are. Okay, so this one right here is going to be A, this is going to be B, and this is going to be C. Okay, so what we're going to do first, and the first step is multiply A and C. Okay, in this case, when we multiply A and C, it's going to be 2 times 4 equals 8. Okay, now the next step, step 2, is set A equal to 1 and C equal to the new number. C is going to be equal to A times C, which in this case is going to be 8. You're always going to set A equal to 1, but C is always going to be A times C. So now what we're going to do is rewrite that first the first part as a different part. So we're going to take it, let me take it, and I'm going to rewrite it. Okay, so that becomes a 1, and then this becomes an 8. Alright, now if you noticed in the beginning when I had a 2 and a 4, I really couldn't factor it as easy. But right now, I can sit there and I can start thinking about, oh, that's a nice little factoring. So, this part is factor new trinomial. Okay? And so what we're going to do is factor into 2 sets of parentheses, x plus 8 and x plus 1. Okay, because remember, 1 times 8 is equal to 8, and 1 plus 8 is equal to 9. That's where we got that from. Okay, now here's going to be the tricky part. Is what I'm going to do is I'm going to take, for step number 4, I'm going to put original A back into each parentheses and factor Well, let's take this one step at a time. In front of x. Okay? Alright, so I'm literally going to put it back in. So it's going to be, instead of x plus 8, it's going to be 2x plus 8 and 2x plus 1. Okay? Alright, step 5, factor out GCF. Okay, so it's going to look like this. 2 parentheses x plus 4. So I can factor 1 out of there, but I can't factor out of the other one, so I'm just going to leave it as 2x plus 1. Okay. Oops, let's get rid of that parentheses. There we go. Alright. And the last step, step 6, throw away GCF. And you have your factored form. Voila! You have your factored form, and the factored form is going to look a lot like this. It's going to be parentheses x plus 4, 2x plus 1. Now you're probably asking yourself, wow, Mr. Vanny, that is a great math trick, but does that really hold up? Well, if you go back to the beginning, let's put a 2 in here and a 4 in here. If we go back to the beginning and check it out, okay, if we were to FOIL, this should work. Because if you remember, factoring is reverse distribution. So we go x times 2x and we get 2x squared. Okay. We go x times 1, which is 1x. So it's going to be a plus a 1x. Okay, and then we go 4 times 2x, which is going to be an 8x. So it's going to be plus 8x. And then we go 4 times 1, and that's going to be a 4. Okay, and if you see, we can only add up two like terms. So we should get 2x squared plus 9x plus 4. And if you follow the steps correctly, it should work every time, to where you, when you get done factoring, you should be able to distribute again or do FOIL and get the same answer as what you began with. Why would you want to do that? I don't know, but I do know this. Factoring always makes your job in math easier. I always tell my students, factoring always makes your job easier. Let's try to make it easier every time. Let's do some more problems. Okay, so on here we're going to go 6 times 1, that is 6. So we get rid of the term in front, so this is x squared plus 5x, and then we put a plus 6 at the end. Okay. Alright, so we factor that. What two numbers multiply to give me 6 but add up to 5? And that would be 2 and 3. Okay. Alright, and then what we do is we put the 6 back in. So this is 6x plus 2, and this is going to be 6x plus 3. Okay, so we factor out this as much as we can. So we're going to factor out a 2 out of the first one. So it's going to be 3x plus 1. And the second one is going to be factoring out a 3. So that's a 3 times 2x plus 1. Okay, and we cross out the 2 and 3 because they don't exist anymore, and you'll understand why later. They actually disappear. There's actually a good mathematical reason why. Alright, and so we're left with 3x plus 1, 2x plus 1, and voila, if you check that with your FOIL, you should see it work the same way. Okay, I'm trying to get through as much of this as possible. So 5 times, now this one's going to be 5 times a negative 2, so this is going to be a negative 10. So the sign does matter. So now we have m squared minus 9m minus 10. Okay, and as you can see, a lot of these are going to be pretty simple stuff. So this is m So what two numbers multiply to negative 10 but add up to negative 9? That would possibly be a positive 1 and a minus 10. Okay, all right, and then we put the 5 back in, so we got 5m plus 1, and then 5m minus 10. Okay, now you can see the first one we can't factor out anything, so we leave it as 5m plus 1. But the second one we can factor out a 5, and we're left with m minus 2. Okay, and we go ahead and get rid of the 5 for now. Just pretend there's a 0 on the other side and you're dividing it into there. That's the actual reason. I don't want to leave you hanging. So this is 5m plus 1. And this is m minus 2, and that's the AC method. Infinitely easier than whatever I wanted to work on. Okay. All right, now this one right here, 6 times negative 12. So it's going to be 6 times negative 12, which is going to be a negative 72. Okay, so this is going to be r squared minus r minus 72. Okay, now you want to pretend like there's a 1 there. Whenever you see just the letter alone, just put a 1 in front. Okay, so what two numbers multiply to negative 72 but add up to negative 1? I think it would be negative 9 and 8. R minus 9 and r plus 8. Okay, now I'm going to put the 6 back in. So this is 6r minus 9 and 6r plus 8, and you're probably seeing a really nice pattern with this. Okay, so now the first one I'm going to factor out of 3, so this is 3 times r, nope, sorry, 2r minus 3, so that's a really nice looking thing, and out of this one I can factor out a 2, so this is left with 3r plus 4. And if you ever wonder, did I factor out enough? You're probably going to sit there and go, I wonder if I did. Okay, well, you'll see more common terms that you can bring out with it. Okay, so this is going to be 2r minus 3, and this is going to be 3r plus 4. Okay, remember we got rid of the 3 and the 2 greatest common factors, so we left those out. Okay, all right, so on this one, it's going to be 4 times 1, which is just 4. Okay, and so we rewrite this as k squared minus 5k plus 4. Okay, we think of two numbers that multiply to 4 but add up to negative 5. Remember, the negative is a huge essential part, so it's going to be minus 4 and k minus 1. Okay. Right, and I'm going to put the 4 back in, so we got 4k minus 4 and 4k minus 1. Okay, so I'm going to factor out the 4 in the first one, so I'm left with 4 in front, and I got a k minus 1 inside, and then I'm going to be left, I can't factor out anything, so this is going to be 4k minus 1. Okay, and I just get rid of that k at the end. And I'm left with k minus 1, 4k minus 1. Oops, get that right. Okay, so as you can see, you can do 4 problems pretty fast if you take your time working with it. Okay, all right, that's it for factoring using the AC method. Please make sure you factor as much as you can, because it always makes your job easier. And follow these methods as I go, and you'll be able to do it as fast as I can. All right. Thank you. Have a great day. Bye.